Hello students, welcome to this lecture 1 probability theory. Okay, so in this lecture we will discuss NCERT section 14.2.4 example number 5 to 8. So I hope your preparation is going well. So this is disclaimer. So first we will discuss probability of the event not A. Okay, so not event A that is also called complement event. Okay, so we will discuss probability of the event not A, that is called complement rule. And then we will discuss example 5 to 8. Clear? So students, first of all, make sure you have with your notebooks and pens ready. Okay, so let's get started. Today's first topic, probability of event not. In our previous lecture, we have discussed probability of event A or B. Okay, and there we have studied the formula probability of A union B. This is equal to probability of A plus probability of B minus probability of A intersection B. Okay, and we have also proved it. Okay, so today we will discuss probability of event not A. So for that we first consider the event A. So event A is containing the elements 2, 4, 6, 8. Okay, and the associated experiment is basically here drawing a card from a deck of 10 cards. Okay, and the cards numbered from 1 to 10. Clear? So clearly the sample space is S equal to 1, 2, 3, 4, 5 up to 10. Okay, so the corresponding sample space of the experiment of drawing a card from a deck of 10 cards is S equal to set 1, 2, 3, 4, 5, dot up to 10. Okay, since we have numbered the cards from 1 to 10. Okay, clear? And we have taken here the event is set 2, 4, 6, 8. Clear? And if all the outcomes 1, 2, 3, 4 up to 10 are considered to be equally likely. Okay, so previous day we have also discussed what is equally likely. Okay, so when each outcomes has equal chance to occur, okay, then the outcomes are called equally likely. Clear? So all the outcomes here 1, 2, 3, 4 up to 10 are considered to be equally likely. Okay, note this point. So what will be the probability of each outcome? So since all the outcomes are considered to equally likely, and here we have 10 outcomes. Okay, so the probability of each outcome should be 1 by 10. Okay, so previously we have discussed if n outcomes are equally likely, then probability of each outcome is 1 by n. Okay, so here we have 10 outcomes 1 to 10. Okay, and they are equally likely, so probability of each outcome is 1 by 10. Clear, students? So now what is the probability of A? So here if the event A describes the set 2, 4, 6, 8. Okay, so probability of event A is nothing but probability of 2 plus probability of 4 plus probability of 6 plus probability of 8. Okay, so since the probability of each outcome is 1 by 10, so what will be probability of 2, probability of 4, probability of 6 and probability of 8? So each of the outcomes in the event A, okay, probability of each outcome is 1 by 10. So probability of A, this is equal to 1 by 10 plus 1 by 10 plus 1 by 10 plus 1 by 10. 4 times 1 by 10. Okay. So this is equal to 4 by 10. And if we simplify it, then you will get this is equal to over 5. Okay. So probability of A is nothing but 2 over 5. Clear? So also event not A. So what is not A event? So the event is 2, 4, 6, 8. Clear? So not A event means we will take those outcomes. We will take those outcomes which outcomes is not in A but in sample space S. Okay. So the not A event is nothing but the set 1, comma 3, comma 5, comma 7, comma 9, comma 10. Okay. Since 1, 3, 5, 7, 9, 10 are not in the event A but in sample space S. Clear? So the event not A that is denoted by A complement, this is equal to 1, comma 3, comma 5, comma 7, comma 9, comma 10. Okay. Clear? And now, what is the probability of not A? So, what is the probability of not A complement? Not A is also called complement of event A. So, probability of A complement is nothing but equal to probability of 1 plus probability of 3 plus probability of 5 plus probability of 7 plus probability of 9 plus probability of 10. Okay. And since we already known the probability of each outcome is 1 by 10. Okay. So probability of A complement, this is nothing but equal to 1 by 10 6 times. Okay. This is equal to 6 by 10. And after simplifying, we will get this is equal to 3 over 5. Okay. So probability of A complement, this is equal to 3 over 5. Clear? So this is how we find probability of event not A. Clear, students? So this is the way we can find probability of event not A. Okay, students? So now thus probability of A complement, this is equal to 3 over 5. Okay, we have calculated already. So we can rewrite 3 over 5 as 1 minus 2 over 5. Okay, can we write it? So probability of A complement, this is equal to 3 over 5 and it can be written as 1 minus 2 over 5. Okay, and we have seen probability of event A is equal to 2 over 5. Okay, so in place of 2 over 5 we can write probability of A. Okay, so probability of A complement, this is equal to 1 minus probability of A. So we obtain here the formula probability of A complement, this is equal to 1 minus probability of A. Okay, so by this example we obtain an important formula. Okay, so this is the formula. By using this formula we can find probability of event not A. Clear, students? And also we know that A complement and A are mutually exclusive. Okay, so you can easily verify it. A complement and A. Okay, if you take intersection of A complement and A, then you will get empty set. Okay, so A intersection A complement, this is equal to empty set. Okay, so A complement and A, okay, are mutually exclusive events. Clear? And if we take union of A complement and A, then we will get sample space S. Okay, so A union A complement, this is equal to sample space S. So A complement and A, these two events are also adjunctive events. Clear? So A complement and A are mutually exclusive events and also adjunctive events. Clear? So we know that A complement and A are mutually exclusive and adjunctive events. That is A intersection A complement, this is equal to empty set, and A union A complement equal to sample space S. Or we can write here probability of A union A complement. This is equal to basically probability of sample space A's. Okay. Since A union A complement is sample space A's, so probability of A union A complement, this is equal to probability of S. Clear? So now use exams 2. So try to remember exams 2. So in exam 2, we have seen probability of each outcomes. Okay, sum of the probability of each outcome is always 1. Okay, and in exam 3, we have seen if two events are mutually exclusive events, then probability of A union B, this is equal to probability of A plus probability of B. Okay, so now we are going to apply exams 2 and 3. Then we will obtain this equation, probability of A plus probability of A complement equal to 1. Okay, why 1? Because probability of sample space A is always 1. Okay, so probability of A plus probability of A complement, this is equal to 1. Or we can write it probability of A complement, this is equal to probability of not A. Okay, and this is equal to 1 minus probability of A. So we constructed here this formula, probability of A complement, this is equal to 1 minus probability of A. Okay, so note this formula. This formula is very important formula. We will use this formula to solve many problems. So now we consider some examples and exercises having equally likely outcomes unless stated otherwise. Okay, so now we will explore some examples. So see example 5. So first of all, read the example very carefully. Okay, so what we have given in this example. So read the question. One card is drawn from a well shuffled deck of 52 cards. Okay, so you are drawing a card from a shuffled deck of 52 cards, and here we have if each outcome is equally likely. Okay, what does mean? So each outcome has equal chance to occur. Okay, that means now calculate the probability that the card will be first a diamond card, second the card will be not an S. Okay, and the card will be a black card. Okay, that is a club or spade. Okay, so there are two types of black card, so club or spade. Okay, or the probability that the card will be not a diamond card. Okay, and then calculate the probability that the card will be not a black card. Clear? So students, how would you approach this example? Think about it. Okay, which concept we can use here to solve this example. So see, when a card is drawn from a well shuffled deck of 52 cards, so what is the number of possible outcomes? So there are 52 cards. Okay, so there are 52 possibilities. Okay, so the number of possible outcomes is here 52. Okay, and this is actually cardinality of the sample space. Okay, so cardinality of sample space is basically here 52. That means number of elements in sample space is 52. Clear? And now we let here A be the event. The card drawn is a diamond. Okay, so we first take the event, that is here the card drawn is a diamond. Okay, suppose you have drawn a card from a well shuffled deck of 52 cards and that card is a diamond. Okay, so this is our event. So now find how many outcome you will get which is a diamond. Okay, so clearly the number of elements inside A is basically 13. Okay, so you all know a well shuffled deck of 52 cards has 13 diamonds. Okay, 13 diamonds. So the number of elements in set is 13. Clear? And now, what is the probability of the event A? So we have studied in previous lecture. Probability of A is nothing but equal to number of outcomes favorable to the event divided by number of total outcomes. Okay, so probability of A is equal to number of elements in set A divided over number of total possible outcomes. Okay, and here you can see number of elements in set A is 13. Okay, and the number of possible outcomes is 52. Okay, so therefore probability of A, this is equal to 13 divided over 52. Okay, and here you can simplify it, and then we will get this is equal to 1 by 4. Okay, so probability of the event A, this is equal to 1 by 4. So that is the probability of a diamond card is 1 by 4. Okay, so we obtain here the probability. Okay, the probability that the card will be diamond card. Okay, that is here 1 by 4. So now we will calculate the probability that the card will be not an is. Okay, so we assume that the event card drawn is an is. Okay, is basically B. Okay, so B event is basically the card drawn is an is. So therefore, card drawn is not an is, should be B complement. Okay, so we studied in previous slide. Okay, so B complement is basically not B event. Okay, so the card drawn is not an is, should be B complement. And we know that probability of B complement, this is equal to 1 minus probability of B. Okay, and here you can easily find probability of B. Okay, so what is probability of B? So probability of B is nothing but number of elements in set B divided over number of total outcomes. Okay, and here the number of ace cards in shuffle deck of 52 cards is 13. Okay, uh, ace card, this is 4. Sorry, so the number of elements inside B is 4. So there are 4 cards, which cards basically ace card. Okay, so probability of B complement, this is equal to 1 minus probability of B, and here probability of B is basically equal to 4 over 52. Okay, so this is equal to 1 minus 4 over 52, and after calculating you will obtain probability of B complement, this is equal to 12 divided by 13. Okay, so probability of B complement, this is equal to 12 over 13. So now we will find the probability that the card will be a black card. Okay, so let here first C denote the event. Card drawn is black card. Okay, so how many black cards are in a well shuffle deck of 52 cards, students? So there are number of elements in set C. This is equal to 26 because uh, in a well shuffled deck of 52 cards, there are 26 cards. They are black cards. Okay, so the number of elements in set C is nothing but equal to 26. Okay, and what is the probability of C? So probability of C is nothing but equal to number of elements in set C divided over number of total outcomes. Okay, so probability of C is equal to 26 divided over 52, and this is equal to 1 by 2. So probability of the card drawn is black card is 1 by 2. Clear? So thus probability of a black card is 1 by 2. So I hope it is clear to all of you. Now we will calculate probability that the card will be not a diamond. Okay, so we assume in first. Okay, we already calculated the probability that the card will be a diamond. Okay, so we assumed in one above that is the even card drawn is a diamond. Okay, so the even card drawn is not a diamond, may be denoted as a complement. Okay, or not a event. Okay, and we know this formula, probability of not a, that means probability of a complement, this is equal to 1 minus probability of a. Okay, and we calculated already probability of a is 1 by 4. So probability of not a, this is equal to 1 minus 1 by 4, and this is equal to 3 by 4. Okay, so probability of not a, that means the probability that the card will be not a diamond is 3 by 4. Clear, students? Now we will calculate the probability that the card will be not a black card. Okay, so the even card drawn is not a black card, may be denoted as C complement. Okay, and we've already we've already find the probability of C. Okay, and here the card drawn is not a black card, may be denoted as C complement or not C. So, and we know that probability of not C, this is equal to 1 minus probability of C. Okay, and the probability of C is 1 by 2. So, probability of not C, this is equal to 1 minus 1 by 2. And this is equal to 1 by 2. Okay, so the probability that the card will be not a black card, not a black card is 1 by 2. So, therefore, probability of not a black card is 1 by 2. So, I hope all the probabilities, okay, that the card will be a diamond card or not an S or a black card or not a diamond or not a black card. Okay, and how we calculated, I hope it is clear to all of you. Okay, simply we use here sim ekdam we use here classical definition of probability. Okay, and we used probability of not a, this is equal to 1 minus probability of a. Okay, and very simple example. So I hope this is clear to all of you. So now let us move to the next example. So first read the example number 6. So first read very carefully, okay, and try to understand what we have given and what we have to calculate. Okay, so see here, a bag contains 9 sticks, of which 4 are red, 3 are blue, and 2 are yellow. The discs are similar in shape and size. Okay, and a disc is drawn at random from the bag. So now calculate the probability that it will be red, yellow, blue, not blue, and either red or blue discs. Okay, so students, try to solve this example first. Okay, so you have 10 seconds 10 seconds to solve this example. How would you approach this example? So your time start now. Okay, students, I hope you try to solve this example. Okay, so now we will solve this example step by step. So how many discs are in bag? So there are 9 discs in all, so that the total number of possible outcome is 9. Okay, so there are 9 discs. So the total number of possible outcomes is 9. And now we let the events A, B, C be defined as A defined as the disc drawn is red. Okay, and B defined as the disc drawn is yellow. And the event C defined as the disc drawn is blue. Okay. Now, number of red discs are here 4. So out of 9 discs, there are 4 red discs. Okay, so the number of red discs is 4. That is the number of element in A is 4. Okay, so n of A, this is basically number of element in A, and this is equal to 4. Clear? And now what is the probability of A? So there are total number of possible outcomes is 9. Okay, and out of 9, there are 4 red discs. Okay, so probability of A is equal to number of elements in A divided over total number of possible outcomes. Okay, so probability of A, this is equal to 4 over 9. Clear? So the probability, okay, the probability that the disc drawn is red is 4 by 5, 4 by 9. Okay, now the number of Euler discs is 2. Okay, that is the number of element in event B is 2. Okay, so now probability of B is equal to 2 over 9. Okay, so there are total number of possible outcomes is 9, and out of 9 there are 2 YOLO discs. So probability of B is equal to 2 over 9. Clear? So now the number of blue discs is 3. Okay, that is the number of element in the event C is 3. Clear? So therefore, probability of C is equal to number of elements in C divided over total number of outcomes. So this is equal to 3 over 9. Okay, and this is equal to 1 by 3. So probability that it will be blue discs is equal to 1 by 3. Okay, and clearly the event not blue is basically complement event of C. Okay, that means not C. So, and we know that this formula, probability of not C is equal to 1 minus probability of C. Okay, so we all know this formula, and now we will apply this formula to calculate probability that it will be not blue ticks. Okay, so therefore probability of not C, this is equal to 1 minus probability of C. Okay, and probability C is 1 by 3. So probability of not C is equal to 1 minus 1 by 3. Okay, and if we simplify it, then you will get this is equal to 2 over 3. So probability of not C, this is equal to 2 over 3. Clear? And now the event either red or blue, okay, may be described by the set A or C, that is also denoted as A union C. Okay, and we already know how can we find probability of A or C. Okay, so since A and C are mutually exclusive events, why? You can check it. A intersection C is empty. Okay, there is no common between the event A and C. Okay, so A and C are mutually exclusive events. So we have this formula, probability of A or C. This is equal to probability of A union C. Okay, and this is equal to probability of A plus probability of C. Okay, so when it happens. So if A and C are mutually exclusive events, then probability of A union C equal to probability of A plus probability of C. But in general, probability of A union B does not equal to probability of A plus probability of C. Okay, so that case formula is basically probability of A union C equal to probability of A plus probability of C minus probability of A intersection C. But here A and C are mutually exclusive events, so probability of A intersection in A intersection C is basically 0. Okay, so probability of A union C equal to basically probability of A plus probability of C, and we already calculated probability of A, that is here 4 by 9. Okay, and probability of C is 1 by 3. So simply add them. So you will obtain 4 by 9 plus 1 by 3. And after simplifying, you will get this is equal to 7 by 9. Okay. the probability of A or C, this is equal to 7 over 9. Clear, students? I hope all the parts of this example are clear to all of you. Okay, very simple example. Just we first define the events, okay, and then we use some formulas, basic formulas, okay, like probability of A union B equal to probability of A plus probability of B when A and B are mutually exclusive, okay, and we use here probability of not A, this is equal to 1 minus probability of A, okay, simple. So I hope it is clear to all of you. So now let us move to the next example. So students, first of all, read the example very carefully, okay, and try to understand what actually want to say this example. Okay, see, two students, Anil and Asima, appeared in an examination. Okay, and the probability that Anil will qualify the examination is 0.05. Okay, so we have given here probability that Anil will qualify the examination is 0.05, and the probability that Asima will qualify the examination is 0.10. Clear? So note this point. The probability that both will qualify the examination is 0.02. Clear? So we have given also here probability that both will qualify the examination is 0.02. Then find the probability that both Anil and Asima will not qualify the examination. Okay, this is first part of this example. And then second part, at least one of them will not qualify the examination. Okay, and the third part, only one of them will qualify the examination. Okay, so find the probability of these three part. Okay, so students, first of all, think about this. How would you approach? Okay, which concept or formula you can use to solve this example? Okay, think about this. So we will solve this example now. So first we let here E and F denote the events that Anil and Asima will qualify the examination. Okay, so E event denote E event basically describes the event that Anil will qualify the examination. Okay, and F event describe that Asima will qualify the examination. Okay, and given that probability of Anil will qualify the examination is 0.05. Okay, that means probability of E is equal to 0.05. Clear? And then the probability of Asima will qualify the examination is 0.10. Okay, so probability of F equal to 0.10. And probability of both will qualify the examination is 0.0. Okay, so probability of E intersection F, this is equal to 0.02. Clear? And then the event both Anil and Asima will not qualify the examinations. Okay, maybe expressed as E complement intersection B complement. Okay, so both Anil and Asima will not qualify the examination. This may be expressed as E complement intersection F complement. Okay, note this point. And since here E complement is basically not E, okay, that is Anil will not qualify the examination, and F complement is basically not F event. Okay, so that is Asima will not qualify the examination. Also, E complement intersection F complement, this is equal to E union F complement. Okay, this is actually called De Morgan's law. So you all studied in set set theory chapters. Okay, so there you have learned E complement intersection F complement. This is equal to E union F complement. This law is called De Morgan's law. Okay, now probability of E union F, this is equal to probability of E plus probability of F minus probability of E intersection F. Okay, or you can write it probability of E union F, this is equal to basically we can substitute probability of E is 0.05, probability of F is 0.10, and probability of E intersection F is 0.02. Okay. So probability of E union F, this is equal to 0.05 plus 0.10 minus 0.02. Okay. And after calculating, you will get this is equal to 0.10. Okay. 0.13. So probability of E union F, this is equal to 0.13. Clear? And therefore, probability of E complement intersection F complement, this is equal to basically probability of E union F whole complement. Okay. And we know probability of E union F complement, this is equal to 1 minus probability of E union F. Okay. And here our probability of E union F is 0.13. So now we substitute the value of probability of E union F 0.13, then we will obtain probability of E complement intersection F complement. This is equal to 1 minus 0.13. Okay, and this is equal to 0.87. Okay, clear? So now we will calculate probability. At least one of them will not qualify. Okay, so at least one of them will not qualify. It can be also written as 1 minus probability of both of them will qualify. Okay, so just think. Okay, and we already know probability of both of them will qualify is basically 0.0. Okay, so probability of at least one of them will not qualify, this is equal to 1 minus 0.02, and this is equal to 0.98. Okay, simple calculation. And now the event only one of them will qualify the examination is same as the event either Anil will qualify and Asima will not qualify, or Anil will not qualify and Asima will qualify. Okay, that is you can write it E intersection F complement or E complement intersection F. Okay, where E intersection F complement and E complement intersection F are mutually exclusive events. Okay, and therefore probability of only one of them will qualify. This is equal to probability of E intersection F complement or E complement intersection F. Okay, and since they are mutually exclusive, so we can write it as probability of E intersection F complement plus probability of E complement intersection F. Okay, and then you can write it probability of E minus probability of E intersection F. Okay, since E intersection F complement, this is equal to E minus E intersection F. Okay, A difference E intersection F and E complement intersection F. This is actually equal to F difference E intersection F. Okay, so we use this and we obtain this expression probability of E minus probability of E intersection F plus probability of F minus probability of E intersection F. Okay, and now simply substitute the value and then you will obtain the probability of only one of them will qualify, and this is equal to 0.11. Okay, so we calculated the probability that both will qualify the probability that both Anil and Asima will not qualify the examination, and we calculated the probability that at least one of them will not qualify the examination. Okay, and we calculated the probability that only one of them will qualify the examination. Okay, so I hope this example is clear to all of you. So now let us move to the next example. Look at example number 8. Okay, so in this example, we have a committee of two persons is selected from two men and two men. Okay, and what is the probability that the committee will have no men? Okay, and what is the probability that the committee will have one man? And what is the probability that the committee will have two men? Okay, so students, how can you approach this example? Try this example. Okay, we will solve this example now. So the total number of persons is basically 2 plus 2 is 4. Okay. So out of these 4 persons, we have to select 2 persons. Okay. So out of the 4 persons, 2 can be selected in how many ways? So 2 can be selected in 4C2 ways. Okay. So out of 4, you have to select 2. So 2 persons can be selected in 4C2 ways. Okay. And here, no men in the committee of two men means there will be two men. Okay. in the committee. So out of two men, two can be selected in how many ways? In 2C2. That is one way. Okay, one way. So two men can be selected in one way. And then therefore probability of no man is equal to 2C2 divided over 4C2. Okay, and if you calculate it, then you will get this is equal to 1 by 6. So probability of no man, this is equal to 1 by 6. Clear? And then one man in the committee means there is one woman. Okay, so one man out of two can be selected in 2C1 ways, and one woman out of two men can be selected in 2C1 ways. Okay, so together they can selected in 2C1 multiplied with 2C1 ways. Okay, so therefore probability of one man, this is equal to basically 2C1 multiplied with 2C1 divided over 4C2. Okay, and if you calculate it, then you will get 2 over 3. Okay, so probability of one man, this is equal to 2 over 3. And then two men can be selected in 2C2 way. Okay, so hence probability of two men, this is equal to 2C2 divided over 4C2. Okay, and this is equal to 1 by 6. Okay, so probability of no man, this is 1 by 6. Probability of one man is 2 over 3. And probability of two men is 1 by 6. Okay, clear? I hope this example is clear to also to all of you. Okay, so that's all for today's lecture. Thank you very much to all of you.